pleased to have Dr. Andrew Margenot from the University of Illinois, Urbana-Champaign as our speaker. Andrew, can you please introduce yourself for our audience?
Sure thing, Kimberly. Thanks again for having me here. So my name is Andrew. I'm a professor of soil science at the University of Illinois. I was trained in biogeochemistry at UC Davis, and now at the U of I work on a variety of topics that pertain to soils and how they can support human well-being. One of those topics is lead contamination. Soils are a pretty big reservoir for lead contaminants, and that might present risk for people who are using soils in places like Chicago, where there's been a history of lead deposition. And so there's risk from inhalation of soil and also from growing vegetables in those soils. And that's what I'm here to talk to you about.
All right, thank you. Okay, so we're gonna go ahead and get started. Sorry. Andrew, would you like me to pull up your slides, or do you feel comfortable pulling them up?
Yeah, let's see if I can show these. Thanks for offering. Let me see. Is that visible to everyone?
Yes.
All right, perfect.
And everyone, as we are, going through this, please feel free to introduce yourselves in the chat and ask any questions in the chat as we go along.
Just a second here, sorry. Let's try that again. There we go. Okay, cool. Okay, well, so I think we have until, Kimberly said 1 o'clock. You're muted, I'm sorry.
Yes, we have until 1, but we would love for people to interact with you and ask you questions. So we just like to leave, about 10 minutes at the end for people to kind of get some of their questions.
Sure, that sounds great. I'd also like that as well. So if folks have questions, I'll try to keep an eye on the chat box, but I'm also very open, Kimberly, for this to be more of a discussion as we go through slides versus holding questions to the end. So whatever you think is best, Kimberly, we can pause and discuss as things go along. Great. Okay, well, so this is the first of a 3-part series, as Kimberly has said. And this one's going to focus on really where's the lead in Chicago. So this is kind of the overarching title of the 3-part series. The goal for today is to talk about, in the case of Chicago, where lead is in soils. We've conducted some assessments, spatially speaking, of where there's hotspots of lead, total concentrations, and how can we maybe explain why is there this amount where in the city. And as you'll see, it can be challenging to explain spatial distributions of these trace metal elements like lead. Before we get into this though, I want to provide some background overall on what lead is, why do we care about it, and the history of lead in the US, which is a history that helps explain why you might see where lead hotspots pop up in a place like Chicago today. Okay, so first, this work was the result of a small village. It takes a village to do any project like this. So thanks to all these lab members from my group and from other colleagues in Chicago, in particular, advocates for urban agriculture. That's how Kimberly and I connected. AUA has been a fantastic participant in this work, and they are leading a lot of the research and the outreach on urban ag in Chicago. Okay, so again, this is a 3-part series. We're going to focus on part 1, which is on the left-hand panel, and that's simply the question of where's the lead in Chicago and how much is there. Then in the ensuing Lunch and Learn series of this, we'll talk about how safe are crops grown in these soils when it comes to consumption, and can we manage the lead risk? Can we do things like mitigation applications of phosphates, for example, to lock up the lead? But that's a preview for what's to come. So let's talk a little bit about why lead is a health concern in Chicago specifically. What you're looking at is the result of a really nice investigative piece from the Chicago Tribune that was entitled Poverty's Poison. Lead is often thought of as poverty's poison because it tends to stunt human potential, both physically and mentally. So mental retardation, physical stunting, and it tends to increase aggression, though that's been contested in recent medical work. But it's pretty undisputed that, number one, there's, quote, no safe amount of lead in blood samples of children. So this is a recent, meaning in the last couple of decades, conclusion by the CDC. So before the 1980s, there was a big debate about whether lead was a problem. And there was a lot of private sector pressure on government agencies to not do testing or to not have evidence that might suggest that lead compromises human health. And the fact is, lead is a very useful metal. It's pliable. It's the plumber's dream metal because you can bend pipes to get into little nooks and crannies. It's also quite resistant, and it tends to bestow beneficial properties to things like paint. Paint has more shine, it's more durable. That's why lead was put into paint. In gas, it helps prevent knocking of engines. So lead is very useful. Even the Romans were using lead for sweetening their wine. So lots of uses of this metal. The problem is that when it builds up in blood or in the body to certain levels, or really any levels, it can cause problems. Obviously, the dose makes the poison, and that dose is thought to be about 6 microgram per deciliter. And this is what you're seeing in front of you. So what we're looking at is the change in child blood concentrations that are testing above this threshold of 6 microgram per deciliter, which again was a threshold put forward by CDC. I know that might contradict my previous statement, that the CDC also says that there's no safe amount of lead in blood, but they still have to come up with a threshold. So this is overall showing us a good trend, 1995 to 2013. In this span of time, we've seen that the amount or the proportion of children in Chicago that are testing above this threshold has gone down markedly. So we've gone from a lot of red and orange, meaning where over half of children are exceeding that threshold, to largely the light blue, which means that less than 10% are, or roughly less than 20% for the orange yellow, are testing beneath, or that, I'll back up here, that are testing up above that threshold. So long story short, we have markedly decreased the population of children in Chicago who are testing above this threshold of 6 microgram per deciliter. That's a good thing. You might ask how this happened. It was a combination of testing programs at schools. It was a combination of updating old housing stock to strip lead paint from indoors, switching out lead pipes. But there's still certain reservoirs of lead in the urban environment. And one of those would be soils. And there are still some parts of the city, especially the South and the West, as you can see here in 2013, that are still having a fair chunk of children, we're talking 20 to 40% in that yellow color, that are testing above the 6 micromole per deciliter. So this is not to say that we have solved the problem of lead in Chicago, especially for children and their exposure, but rather that we've markedly improved upon it from 1995. There's still work to be done. Now, we still see in the news, this is from this past December, articles like this, and this is local news for sure, but I think most major urban centers in the US have similar news pieces. This is but one example of the situation in Chicago. This is Pilsen, which is just to the west of the loop, is what I believe. I'm not from Chicago, sorry. And there's a lot of industrial activity in Pilsen, a lot of smelting, for example. And as a result of this smelting and construction of railroad ties and steel, there was deposition of trace metal elements, what we call in slang heavy metals, but scientifically the term is trace metal elements. So lead, but also things like copper and zinc have been deposited. Now, when you deposit metals into the environment, be they aerial emissions, like from a smokestack, the back of a tailpipe of a car, etc., those metals go somewhere, and they typically end up in the soil. Now, how much and how deep do they leach through? Do they get washed out? This depends on lots of things, like the metal itself, the speciation of the metal, the soil properties. But by and large, most of these metal loads, the loads that have been put out into the urban environment, they're still there. So a lot of the lead that has been deposited historically is still hanging out in Chicago, and a lot of the sink, or where it's going, is going to be soils. Let's talk a little bit about lead now on the chemistry side. I mentioned that it is a heavy metal. Heavy metal is a very, what we call, operational definition. It's simply a descriptive definition. It doesn't really tell us, though, how the metal acts. So heavy metal comes from the metal literally being at least 5 times the mass of water at a certain temperature. And so that is what lead is, or sorry, lead fits that definition, but so do other metals. And the more strict definition of what we think of as metals of human health concern would be the ones shown in red here. These are metals in the periodic table. EPA has named 5 metals and metalloids. Metalloids are metal-like elements, and especially we're thinking here of mercury. These are the 8 elements in the top right blue box that US EPA has on their list of human health risk. These are of human health concern because they tend to be toxic at low concentrations, and they tend to be historically accumulated as contaminants in soils, waters, and other environmental spaces in the US. I mentioned that a lot of what we've deposited historically in terms of lead into the urban environment is still there. And this is a good depiction of just how much amount, the tonnage, literally speaking, of lead. So what you're looking at here on the x-axis, the bottom would be the year. And on the y-axis would be the amount in terms of thousands of tons. These are metric tons. So for example, where my cursor is being at 1910, this is the beginning of the x-axis. We see 120 on the y-axis. That means that we, in 1910, emitted or had in paint 120,000 tons of lead. So we then have 2 different major colored lines. We've got paint in green, gasoline in blue. And this shows you the major uses of lead. So the major sources of deposition of lead in the urban environment have been leaded gasoline and leaded paint. And as you can see, the use of lead and paint fell off by about the 1940s and 50s, pretty much gone by the 1960s. And concurrently, there was an increase in the lead being put into gasoline. So the total, therefore, actually increased through the 1960s as a result, before sharply dropping by the 1980s. And this was due to increasing recognition and medical research showing that there's a problem if we have lead in the environment, because it ends up in the bodies of children, where again, we have big issues. Now, I'm not denying that, or I'm not trying to downplay that lead is also a toxin for humans, for adult humans, but it is more impactful at a given dose in children because of their development. So if you were to integrate the area, if you go back to calculus, the area beneath the curve would be the total amount of lead that's been emitted in the US. And we're talking on the order of millions of tons of lead have been put out there. Millions of pounds of lead have been emitted historically, largely through these 2 sources. Note that conspicuously absent would be jet fuel. We get this question a lot, especially for Chicago, because we've got Midway and we've got O'Hare. Jet fuel proper does not have lead in it, but that's jet fuel. Small engine plane, like the propeller planes that carry 2 or 3 people, those do use lead. And there's still permission to use leaded fuel in these small engines, but those aren't jet planes that you see at O'Hare or Midway. So that's good news. It's also why, as you'll see from our lead maps of Chicago, why there aren't any hot spots of lead around O'Hare or around Midway. Excuse me. So one final thing to note here is that you can see the gray bars. This is blood lead concentrations with the right-hand y-axis. We can see that the CDC blood level limit of 5 microgram per deciliter, which is a more recent update, gives some context of what's acceptable versus 6 that we saw from the previous slide. What you want to point out here, or fix your eyes on rather, is that as we saw a decrease in the amount of leaded gasoline, beginning about 1970 was the initiation of that drop through 1990, we saw a concurrent decrease in the amount of blood lead in the gray bars. So this is a good example of how policy, that was enacted swiftly, relatively speaking, to decrease the amount of lead being put out into products like gasoline, did translate to appreciable and rather immediate decreases in the blood lead concentrations of children. So a good example of a success story of regulations protecting children from this environmental contaminant. Now, if we look at, that was the US-wide mass balance of lead. If we look at where lead was largely deposited, not surprisingly, the largest amounts of lead being put out track with populations of urban centers of the US. So number 3 in terms of population of any city in our country would be Chicago. And so number 3 in terms of lead deposition is also Chicago, not surprising. So you've got major cities like Miami or LA, New York, Boston, these tend to dominate the top 10 lists. It simply tracks with population. Okay, now note the scale too. The larger the black circle, the more amount of lead was put out. And we can see that we're talking also in metric tons. So we've got hundreds of thousands of metric tons in the case of Chicago or these top 10 cities. So that's why we've had millions of tons of lead being put out across the whole country. Now, I think it's good to maybe pause here and talk a little bit about the question of how much lead in soil is too much. So lead, the symbol here is PB, from Latin for pumice, because that's how you would make pipes for plumbing. The way that we typically measure lead is as a concentration. And so there's different ways of measuring concentrations, as say a percent. But the way that we express very low concentrations in chemistry is typically as a parts per million. So this is 1 unit to express this would be milligram per kilogram. So if you imagine 1 kilogram, about 2.2 pounds. 1 milligram, a grain of sand, roughly speaking, is what 1 ppm would be. So if you take 1 liter of water, that's about a kilo. In terms of mass, 1 grain of sand, weight into 1 liter bottle of soda, that's roughly 1 ppm, to give you some sense of what concentration is. Now, these are total concentrations that we're discussing. And more on that in just a second, but it's maybe not the best way to estimate human health risk or plant uptake risk. But for our purposes, it's going to serve. Now, naturally, lead is everywhere. I guarantee you had lead for breakfast this morning. The question, of course, is how much? It might have been ppb or ppt even, probably more like ppb or even ppm at very low levels. A good example also would be for other metals like arsenic or cadmium. You are consuming these, but of course the dose makes the poison. ppm then is the typical scale at which we see lead manifesting in soils. Now, naturally, soils have about 20 to 22 part per million or ppm. This varies across the US. It might be a little bit higher in the Northeast, a little bit lower in Florida, but in Illinois and in much of the Midwest, we're roughly around 19 to 21, maybe 22 ppm. Now, this lead came from geogenic, meaning geological sources like the rocks from which soils are born. This is natural, and it's largely unavailable. So if you eat soil, even from a farm that's pristine, you're unlikely to get lead poisoning from consuming that soil. So no reason to be alarmed. If you send off your garden soil for a test and you get back a total lead of say 20 ppm, good, you should actually have that. Now, the question becomes, well, as we increase above this natural background, how much lead becomes too much lead? And that's a good question. We don't have an answer to how much is too much, but there are agencies that propose, based on the precautionary principle or course models, how much may be too much. So the threshold that we find from the California or the Minnesota EPA, which are more conservative in terms of being careful, would be 80 or 85 respectively for these 2 states. Now, the California EPA is based on some data. They modeled based upon a typical soil, and those of you that know soil science are laughing because there's no such thing, but sure, if we assume a typical soil in California, and we assume a certain amount of childhood exposure via playing in the soil and being inhaling or ingesting soil by putting, say, fingers into mouth. You can assume a certain load of lead into their blood. And by linking a known amount of blood lead concentration to known decreases in IQ, the California EPA then was able to model and to estimate that 80 to 85 ppm is permissible before there is a not okay decrease in IQ of children. I know that IQ is not a great metric. This is not my metric. This is the California EPA. This is what they're doing. So the EPA of California at least is using some data, some modeling to try to estimate their threshold. If we go forward, the US, or the federal EPA, which is also what many states, including Illinois, follow, is 400 ppm. So note that California and Minnesota are roughly 4 times above natural, right? From 20 to 80 is around 4-fold increase, or 85. And then if we go from 20 to 400, that is a 20 times increase above natural. And this is again what the federal and also Illinois EPA and the Chicago are using as the threshold of what is maximally permissible for total concentration of lead in soil if it's exposed. And this is the key word. We're not talking about growing crops or a garden. We're talking about if there's no grass, it's dry, kids are picking up soil and thus dust, then we have a problem because of inhalation risk. Now we can keep going up the scale to 600 ppm. This is what the EPA, again, federal, sets for residential areas near Superfund sites, which is basically if they've done a Superfund cleanup, they need to get down to at least 600 ppm. And then we have 1200 ppm as, again, federal EPA threshold for bare soil in non-play areas. So notice that play for children areas is 400. If kids aren't playing, you can get up to 1200, so 3 times higher than that. And that itself is well above the 20, right? We're now many orders of magnitude above that, or at least a couple orders of magnitude. So this is all to say that there is a gradient of what constitutes permissible, and there's not a whole lot of data. I know there's a few scientists on this call, so if any of you have any experience with this, like Dr. Popova, good to see you here, then I'm all ears. But we've talked to the Illinois EPA about why 400. We can't get a straight answer on this. It strikes me as more of a precautionary principle based on 20 times as a round number above the 20 ppm background. So I want to really stress, folks, that if you try to go to Google, we've done this in our lab, trying to come up with recommendations to our stakeholders, people who have urban gardens in Chicago, we don't really have a good answer for them. And there's not a whole lot of peer review evidence on what constitutes a threshold. Now, this, to be fair, might be because it's a very complex problem. Depending on how much clay content, what your soil pH is, the amount of bioaccessible lead, which is the fraction of the total that is going to actually translate into a digested and thus in the body amount of lead from the soil, that is going to be very dependent on context. So it's difficult to come up with blanket recommendations. So this is, I think, a combination of insufficient research, but also the complexity of the challenge. What I want you to take away from this for what we're about to see for Chicago is 20 ppm is natural. 80 is probably what we should be following if we're being careful, because again, California is at the forefront when it comes to environmentally cautious thresholds. And 400 is what the federal and the Illinois EPA says is a problem. Okay, now, many cities, based on these broad recommendations, have mapped lead concentrations, and really not cities in terms of city governments, but researchers have mapped in certain cities. And a good example of this would be this paper from about 9 years ago in New Orleans, where they took a grid sample approach. Grid sampling means that you walk a certain frequency, a certain interval across the city, or anywhere actually. You take a soil sample from the surface depth typically, and you measure a variable. And in this case, it would be total lead concentration. So, and you can then interpolate, you can basically blend those specific single points, and you can make a map by a process called kriging. We won't get into those details here, but basically we can make a really nice visual to look at the hot spots. As you can make out from the legend, which is numbers expressed in units of part per million, the milligram per kilogram or ppm, This is a nice way to visualize areas that are low spots that are typically safe for background versus areas that are hot spots and therefore are a reason for maybe to take precautions. Now, these maps are useful because they can help you identify where the lead is, roughly how much there is, and it's a first step to inform more detailed follow-up. These kinds of maps, folks, are not meant for you on your specific household scale, at the lot scale, to determine whether or not you have a risk. They're a first step to say, oh, I'm in a hot spot region, I'm at a high risk, I should get tested. In contrast, if you find yourself, say, way out here, probably no need to worry. But if you're maybe here, might want to invest in a somewhat expensive lead test. So that's an example of a city that had its soils mapped for lead concentration. There was no such map for Chicago. So beginning in 2018, my research group here took on the task with some financial support from the campus, as well as collaboration with AUA to understand where is the lead in Chicago and just what's the degree of contamination. So we went about this in two ways. We wanted to understand lead in public areas, in soils specifically, and also in private backyards. But of course, it takes a lot more effort in terms of time to ask for permission to go door to door. So for us to get a citywide map, we did both. We did parkway soils, which are in Chicago defined as public spaces. These are the grass strips or the median strips that are between the road and the sidewalk. Now, there's all kinds of issues with this. For one, they sometimes are made for using local fill, but for that reason, they give us a local, meaning a neighborhood level or assessment of lead concentrations in soils. And we've sampled these parkways every 650 meters. So we spend about 3 months driving around the city, stopping every 650 yards roughly, getting out of the car, taking soil samples at each location. So this gave us a total of 1,000 sampling locations of parkways shown on the left-hand map here. We went to 6-inch, 15-centimeter depth, and we took 2 soils at each location and we analyzed those separately just to look at the variability within each site. This is a sampling density of about 1.6 samples per square kilometer. For reference, other studies typically have much lower densities of about 0.05 or 0.5. So it's a fairly high density, all things considered. At the same time, we also wanted to understand backyard contamination. And herein we had a question of, can you get the same results? Do you get the same map of soil lead across Chicago if you sample the backyards or if you sample the parkways? Because if you get the same result, that's great news. It means that you can sample publicly accessible parkways and get a first pass assessment like what we saw here. But if they're very different, that means we have to do backyard or private property sampling, which just simply takes time. So for other cities or for other parts of the city of Chicago to get high resolution maps, we wanted to incorporate this methods question. Okay, so how do we get access to private property? Well, we didn't go there. We asked people to do it for us. So we did citizen science, which is simply we asked inhabitants or residents of Chicago, hey, if you send us your soil sample, either at a booth we had at certain events in the city, or if you mail them into our lab at the U of I in Champaign, about 2 hours south, we will give you a free soil screening by portable X-ray fluorescence. We'll give you a number, which is an estimate. It's not a certified lab test, it's an estimate, but it's free and it gives you a ballpark. In exchange, we'd like to ask for the location, the street address of your sample, and for your sample. We get to keep it because then we can do more rigorous analysis of lead. And thereby we can build this geo-reference library so we can pinpoint the amount of lead to the location. We only got 156 soils. I mean, only, I don't mean to say that that's not bad or that that's not good, excuse me. That's pretty good. I mean, only relative to the parkway. So we have a bias in the sampling approach. I still want to really thank those folks who sent us their samples. We were able to get some insight into these backyard soils. So this is an example of what we were doing for some of this outreach effort. This is Liz Murneke and Zach Grant from U of I Extension. We would go up to Chicago for these urban ag events, and we would say to people, place a pin on the map when you give us your soil so other people later in the day can see what they're adding to. I think it's a nice way to illustrate in a citizen science approach the communal effort of this sampling. So here are the results. Yeah, this is what they look like. So I want to walk you through them. On the left-hand side, we have the parkway-based map. So this is the roughly 1,000 samples from publicly accessible parkways that our team sampled. Again, top 6 inches. On the right-hand side, also the surface soils, the 156 soils that were mailed in or brought to us from people's backyards. And the legend is very key to note. Notice that we are again in part per million ppm for total lead concentration across the city of Chicago. And we've got five major tiers based upon these increments of 100, 200, etc. Now, these are colored based upon the correspondence to thresholds of concern. They're not stepwise. So we're going from the first 2 shades by 100 ppm, but then we're doubling, and then we're increasing again by 200, again, because we have 400 is the EPA limit for Illinois in the federal EPA. 1200 is going to be the non-exposed soil federal EPA and also the state EPA limit. Now, if you kind of glaze your eyes over and gloss over, we see overall a similar pattern of lead concentrations across the city, whether we use parkways, public, or whether we use these backyard residential, i.e. private soils. So we have, in other words, very low concentrations on the outer ring of the city. And as you go towards the inner loop, which is here in white because we couldn't sample the loop, it's all concrete, we get more hotspots. Now, it's not very uniform in terms of the hotspots on a transect. So if you were to go in towards the inner part of the city, towards the loop, it's not like you're guaranteed to get a steady increase, but rather we see splotches or these hotspots that are irregular but ringing, roughly speaking, the central part of the city. And note that the very, very highest amounts, which is the dark purple color right here, we see it manifesting in some of these regions, really in the southeast part by the lake. But these other hotspots we see are the lighter shade of red. These are going to be above 600, but under 1200. Now note that 400 is in the orange color. So on the whole, most of the city is under or at or under 400 ppm. That's a good thing. Now I want to show the combined map. So if we combine the samples of the parkway and the backyards, we get this map. So not a huge change if you look at these together. That's a good thing because, as I just said a few slides previously, it means that cities or neighborhoods in Chicago can use the parkways as a very rapid assessment of lead risk in the city. They don't have to go door to door and knock on backyards. I just saw a question from Robert. Can we get a copy of the slides? Robert, I'd be happy to give these to you. Yep. Okay, so let's talk about some of the data in more detail. So I'm going to walk through the parkway first. We see that the range of the parkway soils in terms of total lead concentration in the red box here. We did not find a single soil in the parkways that were natural. So the minimum concentration was 44 ppm. Again, natural is 20. And the highest we saw was 1650. So it's 1,650 for the total lead concentration. So that is well above our 20 ppm limit. Now, notice that we have the median and the mean. When we have a skew distribution like in these soils, the median is the more accurate way to think about the average. So let's use the median for our discussion. We're almost exactly actually 11 times above the natural concentration of 20 ppm because the median in the parkways is 220 ppm of total lead concentration. So in other words, highly variable across the city. And on average, we have more than a 10-time enrichment or increase of lead over what we would expect. Now we've got other soil properties here just for context. Now we've got pretty alkaline soils. This is relevant, as we'll see in the next Lunch and Learn series, because at high pH, you tend to make lead less available for human uptake. And also naturally, pH in this part of the country should be about 6.5. So this speaks to the amount of alkali deposition through construction materials like concrete in the city. That's a story for a different day. We also have very high amounts of phosphorus, not very high, but higher than what you'd expect. Olsen phosphorus is a median of about 10 ppm. This is also relevant because this can mitigate the bioaccessibility and thus the risk of lead uptake and absorption by the human body. So I bring up these properties of soils because they are somewhat relevant to interpreting what does this mean in terms of lead contamination. So that's parkways. If we look at the backyards, we find that they're typically more extreme than the parkways, both at the minimums and at the maximums. So here we did see some backyards that were just about normal concentrations of lead, what you'd expect naturally, 23 ppm, but we also saw higher highs or more extreme highs, so up to over 3,300 ppm in some backyards. Now, in these same backyards, we did measure sources of lead, namely paint chips that were about 25,000 ppm. And the gardens that were being sampled were right next to these walls that had old lead paint chips. So one recommendation that you might take away from this is that test the old paint chips that are on your home and try to avoid gardening in soils that are close to an old housing structure that may have received a coat of lead paint prior to 1980. If that paint was stripped and not correctly disposed of, it would have gone to the soil. And that's why we see in these backyards fairly higher concentrations of lead. Now, overall, though, the median was lower than in the parkways. It was 146 ppm versus 220, which might be suggesting that the gasoline deposition of lead into parkways by the roads is a greater source of lead contamination in Chicago. Now, this is speculation. We'd have to do isotopic evaluation of the lead. Lead has different isotopes, and that's just a fancy way of being able to discern the different sources. We have not done that, so we can't say for sure the source of the lead. We're just doing this on a mass basis by looking at by the roads, i.e. the parkways, versus by the houses, i.e. the backyards. Now, what does this mean overall? Well, if you take a more conservative interpretation, i.e. the California EPA, it means that basically all of the city exceeds the threshold of 80 ppm. That's the not so great news. If you take the less conservative threshold of 400 part per million of the US and the state EPA, then only about 1/5 or 20% of the city exceeds 400 ppm. That's the good news. And the good news too is that we don't have crazy hotspots at large scale. We see this very dark red region over here in the southeast part of Chicago. That's pretty high amount. We're talking 1,000 ppm, but that's a small percent of the city. So in contrast to places like Boston or New Orleans, where they have large swaths of their cities that are exceeding 1,000, 3,000 even, we don't see that in Chicago. Now, this might be chalked up to the fact that it's a relatively younger city. The Industrial Revolution just kind of caught Chicago, but compare that to a place like Boston, where the people had been using lead in all kinds of applications since the 1600s. So in general, East Coast cities have higher soil lead contamination than the Midwest, than the West Coast, and we see that borne out here. Now, another question that we might have is, can we explain the concentration? So we see, roughly speaking, as you get towards the loop and as you get away from the loop, and I'm using the loop just as a origin point of the city center, because that's where the city really began, we see that there's in general more lead closer to the loop. But if you simply plot distance from the city center, that relationship is pretty poor, as you can see, whether you do it by parkway or by the backyard residential soils. Not a really good meeting, not a very tight relationship with every kilometer away from the loop. There is a decrease, but it's very loose. And you can make that out from the trends here. We see splotchy hotspots, not a uniform ring or concentric circles. We also tried to model whether things like soil texture, the amount of clay or silt or sand or pH or Olsen, which is a metric of crop available phosphorus, whether these things might help explain the concentrations because they interact mechanistically with lead. Clay tends to bind to lead, higher pH tends to immobilize lead, as does more phosphate. But we did not find any relationships of these soil properties with total lead concentrations. So there's not a really good takeaway here, except that in general, we see these splotchy hotspots near the city center. And as a next step, folks can use this map, which is available in a few places that I'll show you in just a second. They can use this map as a first step to understand if they find themselves, for example, in this part of Chicago versus in this part of Chicago by a hotspot, whether they might want to take precautions in testing and in land use when it comes to lead. I want to also mention, by the way, since we have the map up, O'Hare is around here. We don't really see any hotspots by O'Hare. This makes perfect sense. O'Hare was basically farmland until about, 50 years ago, when there was the beginning of the decrease in the use of lead in paint, and definitely for gas. And again, jet fuel does not use lead. Small engine planes use leaded gas, but small engine planes are not flying out of O'Hare, jet planes are. Same goes for Midway. We don't see any real hotspots around that area either. Okay, so in terms of where you can find this map, I know Robert asked for the slides. If you're looking for the map itself in a way that you can interact with the map to zoom in, there's two resources that I want to direct you towards. One is the publication itself. It was published open access. It means that we, the researchers, pay about $3,000 so that you don't have to pay anything to access it. There's no paywall, there's no subscription fees. So if you Google the title, or if you click the link here, I know you can't click it on Zoom, sorry, you'll be able to access the whole publication with all the jargon and also these maps that you're seeing. You can also go to, well, in the future, the Chicago Urban Ag Mapping Project, or the lovely acronym of QUAMP, quamp.org. We're working to integrate the lead as a layer in the map, layer meaning that you get to select it as something that you can visualize. You also can currently right now go to Map My Environment. This is being done by a group from Indiana University, Dr. Gabriel Filippi. He's a well-known researcher in the world of lead, does excellent work on this topic, and he has initiated this open source project in which you can contribute data on soil, but also indoor dust and water contaminants, not just lead, but also organics and other metals. So mapmyenvironment.org. If you go there, there's a map layer for the whole US for soils. If you go into Chicago, we've added all of our lead data there. So you can interact and you can zoom in even down to the zip code or even the block neighborhood level and look at what your risk might be. Again, these maps are not meant to solely determine your risk. They are estimates because we do some interpolation, basically kriging. It's based on probability, but not actual wet chemistry measurements for the exact location. Okay, so the next part of the series is going to be, what does this mean for urban agriculture? What you see here on the left is the maps that we've generated on lead contamination in Chicago. On the right-hand side, we have maps of urban agricultural sites. This is some really nice work by Dr. Sarah Taylor in the early 2000s or 2010s. And she was effectively mapping the kinds of urban ag, and the green dots are backyard gardens. The red dots on that right-hand map are lot gardens, like vacant lots. And what you find is that there sometimes can be overlap of the hotspots of lead contamination, like right here, with urban gardens, be they private or be they urban lots or community gardens. And sometimes there's a lot of urban agriculture, like around O'Hare, but there's not a whole lot of contamination. That's a good thing. So there can be a mismatch, which is a good thing, or sometimes there can be a coupling, which is a bad thing, of contamination of lead in soils with urban ag. We'll talk about what that means in the next series of this Lunch and Learn. So I think that leaves us with some questions. Basic takeaways here before we get into some questions is we do have widespread enrichment is the scientific term. I'll call it what it is, contamination of soils by lead in Chicago. Median is roughly 10 to 11 times above background. roughly 1/5 of the city of Chicago. This is the city limits defined as such. 1/5 of the city area is above the 400 ppm threshold. This is again for inhalation risk. So we'll talk about next time what this means for crop risk and thus human risk. And finally, the major takeaway is that there can be some potential risk if you're near the loop, but again, consult the map because it's very splotchy in terms of where that hotspot might be. Okay, so I believe we've got 11 minutes for questions. I'd be happy to discuss with the group.
Great. Thank you so much, Andrew. That was amazing information.
Thanks, Kimberly.
And a great resource at the end. So I did see Ina, she put the link to the website again, but there was one question here. Okay, that was that question. I do apologize. But I would just like to open it to our audience to ask any questions. No? Okay, I actually have a few questions. I think this is, this illuminates a lot for us. And just to know or to think that there might have been some lead contamination in the things that we've eaten for breakfast is, not very shocking since, we know that lead is widespread. But as I'm thinking about this, when we think about lead in our soils and thinking about in our backyards, how is it that some of this lead could, possibly be immobilized or suspended if lead might be in the water? It seems like lead contamination will continue to be an issue if you're watering your garden that has water, or you're watering your garden with water that may be contaminated with lead. So I guess what would be a solution if it seems to be like an ongoing issue, if it's, you have water that's contaminated with lead?
Yeah, that's a great question. I would say it's good to keep in mind that water concentrations are typically pretty low. So we're talking about soil concentrations of part per million, and lead in water is part per billion typically. So it's 1,000 times lower in terms of how we measure them scale wise. I'm not a water lead expert, so if there's a member of the audience that knows more, please speak up. But if you do the math, it takes a lot of liters, even thousands of liters of water when it's ppb concentration, part per billion, to contribute to the part per million of the soil. So I would say overall, it should be okay for watering with trace amounts, i.e. ppb concentrations. Obviously, if we can avoid that, that would be a good thing. I'd be more concerned because we're drinking that water and kids are drinking that water. So if it's at a level that might be beneath a human health risk in water, it's definitely won't be an issue for building up in soils lead-wise. It would take many, many, many years and many thousands of gallons of water for it to build up. And luckily in our part of the country, we don't need to irrigate very much for our gardens because it rains so much.
Okay, thank you.
You're welcome.
All right. Does anyone else have any questions? Okay, well, if not, that concludes our part 1 Lunch and Learn series. We do have part 2, as Andrew mentioned. It will be happening August 31st, Wednesday, same time, noon. And so we hope to see you all there for the continuation of this part. I would like to thank Dr. Margenot again so much for being here. And I would also like to thank our partners, Advocates for Urban Agriculture, who introduced us to this amazing professor and his work. So thank you again. And again, I would just like to reiterate, if any of you may not have been a member of IEC, we would love to have you on, and please visit us at the link that I posted in the chat earlier. And if not, if you did not see that, I will place it in the chat one more time. But thank you so much again for coming, and we just want to extend our gratitude for you all being here. So thank you again. And have a great afternoon.
Thanks, Kimberly.
All right. Bye-bye, everyone.
Take care.